A common data structure that is core to so many operations we perform on our computers is a stack data structure. If you ever used undo or redo or used the back and forward buttons in our browser, it's a very good chance the stack data structure is being used under the covers. So in this video, we'll learn a little bit about it and why it works the way it does and what makes it so appealing. But before I begin, I should let you know that if you want to learn more about stacks and other data structures as a part of algorithms, my book, Algorithms, Absolute Beginner's Guide, is just what you need. Available in physical bookstores and online bookstores. Links below, so definitely do check it out. Now, the best way to explain how a stack works is to think about a stack of pancakes. If you don't like pancakes, replace that with waffles, cookies, or whatever food that you can just stack on top of each other. Now, the reason why I'm using this example is the way we add more items to our stack of pancakes is we add items to the top, and the way we take items out from this list of pancakes or stack of pancakes is we take an item from the top as well. So the way to describe it is new items go to the top. The item we take first is also the one from the top as well. So it's kind of an in and out situation here where you don't have to worry too much about the bottom items. The item you add first or item you add last is the one that is the first to be removed. And the stack is a well-known data structure that mimics the behavior we typically see with pancakes. So if we kind of shift our focus from looking at food and looking back at our typical representation of data, which is small units of information, let's say we start off with an item, let's say 1, and with a stack, let's say we want to add one more item to it. If you were to visualize it, you'll see that it gets added to the top. We get a sequence of steps where each item we add gets added to the top, and our stack gets taller and taller, where the oldest item is at the bottom and the newest added item is at the very top. Similarly, if we are removing items from our stack, the behavior is the exact opposite. We take the most recently added item first. So in this case, we have 5, 4, 3, 2, 1 are the items in our stack. The 5 item goes first, then 4, then 3, then 2, and we're left with 1, the last item that we have in our stack right here. There's a name for this kind of an arrangement, and it's known as the last in, first out system, or more commonly abbreviated as LIFO, L-I-F-O. And you can exactly see why it means that same way if you look at the visualization we have here, where in the pancake, the last item in is the first item out, and that's typically the way a stack data structure works. Now, because of this kind of an operation, when we look at the common things you do with a stack data structure, like you add items to it, remove items to it, or you peek is a common operation you perform, which is you don't want to actually take the pancake out. You just want to check and inspect to make sure it's all good. And if you want to search through your entire stack or see how much memory it contains, the performance characteristics or the big O notation for all of them is as follows. Adding an item, it's constant time. You always just add it to the very top of your stack. And removing is very easy as well. There's no concept in a stack of removing just the middle item or the last item. The item you always remove is the one you just added. So it's constant time again. It's the very top item in your stack. Same with peeking, no big deal. You just take a look at the top item, see how it is. Searching requires you to go through every item in the stack. If you want to find an item in the middle, you can't just jump to the middle. There's no concept of index positions or any way of identifying a region. You have to linearly scan every item to get there. And because a stack just contains a linear list of items, and the more items you have, the taller your stack will be. And so the memory is also pretty much linear, so there's no variation there. Now, a common implementation of stack, based on what we've seen here, is using the array object. Because the items are added to the very end and removed from the very end, using an arrays approach for being able to just handle the very last item efficiently is a great approach for implementation. We look at implementation of a stack in a separate video later on, but because of its, using an array behind the scenes, its performance for adding and removing items from a different array is really good. Constant time, which is the notation we saw earlier, which is very, very nice. And of course, learning data structures and algorithms and data structures like the stack can be confusing at times. So feel free to join the forums at forum.group.com and ask a friendly group of other developers for assistance. And if you want to learn more about other content that I create or want to go deeper into any of these topics that my video currently covers, definitely take a look at these resources. And with that, I will see you all next time.